can you please brief about your company? What do you people do?
Yeah. So, NOSH Robotics, as the name suggests, right? It's a robotics company. And what we believe from day one is that new generation, like millennials and Gen Z and upcoming generation, they typically don't enjoy cooking as much. And they depend a lot on like easy to cook, easy to prep, or outside food, right? Which also affect their health. So at NOS, our goal is to build robots that can actually get a personalized and diet prepared meal to everyone, right? So essentially, the idea is that whatever happens in the kitchen, as a company, we want to automate so that anyone can get food anytime, anywhere, right? So that's the overall goal of the company. Um, and how it got started, right? So how it got started was so basically me and my wife both are working, and we are a Guju settle in Bangalore. So we have a very big problem of finding right cook who can cook as per our taste and diet requirement. So with that problem, this idea got inspired, and with that, we when we I spoke to a lot of people who has moved the city or come from outside, lived in a metro city or abroad. We realize that all of them have some challenges regarding the food. They always live at a compromise, right? So that's what we want to solve. Um, that people should get a great food daily, like homely and healthy food every day. That's the goal of the company.
So how does the name come up?
So, actually, so we started the company. In fact, initially we called it Euphotic Labs. The reason was we want to create a happiness, right? So it is like a euphoria automatic. So that's where the Euphotic name came up. But then when we were really kind of doing some surveys, we realized that people were not able to remember Euphotic very well. So we were looking for a name, and that's where one of our friends suggested this name, NOSH, which means no one sleep hungry, right? So it sounded very nice because that's what our goal was, right? So with that we chose this name. And good part about this name is like across culture, across languages, the name is always associated with food. So that way we like this name.
So you have a single product, right? Or you have
Yeah,
multiple products?
one product right now, first product.
One product. What it is capable of doing?
So it can cook anything that you cook in a pan or a pot or a cooker, right?
Okay.
So be it your sabjis, curries, rice dishes, pastas, biryanis, halwa, right? Laddu preparation to your ramen soups, Chinese, chow mein, khao soi, right? So anything that you can cook in a one pot, right? It can cook automatically.
Okay.
So that's the capability.
Okay, so I have a question. Like cooking is a multi-step process, right? It's not like one process at a time. So, what are the core design challenges you faced when you designed such a system, which is automating a multi-step cooking process?
Yeah, so the actually, funnily, right, when we started, we realized that in food everything is complex because um so the challenges are that like initial challenges was to get taste right, right? So our idea is that make automatic cooking and the taste should be right. So that was the first challenge. So getting the accurate spice dispenser, right? Getting a ingredient dispenser which can handle all type of ingredients, like starting from herbs, veggies, meat, something like sauces, right? Pastas. It should handle all type of ingredient, right? So a generalized mechanism which can handle all type of spices, all type of fresh ingredient was one of the big challenge. Then getting the stirring right. So when we cook, like we have lot of degree of freedom. Like when you
Mm-hmm.
move our hand, right, it can
Mm-hmm.
move in multiple ways, multiple direction, and we have like multiple degrees of freedom. Where a robot has to mix it, cook it, it is all about one. Uh, like I can put only one motor or a two motor at max. So that has been the key challenge. The initial days, right? Um, After that, once we prove that taste can come out very well, bringing them in a miniature form factor, like something that can go in people's house or a microwave size, right? That was one of the another big challenge. Third was getting reliability right? So when the food comes in, a lot of things become like reliability become very challenging because something is smooth, something is thick, making sure everything works as per the design. So making a reliable mechanism which will last for like 7, 8 years of usage was another challenge. Then also cleaning and food not deteriorating the system, right? So let's say you have oil dispenser. Now oil is something that polymerize in the system. So how do you make sure that oil doesn't harm the system or the oil dispensing quantity doesn't change over time, right?
Mm-hmm.
So those kind of challenges were the one of the biggest one. Then entire the food angle, right? So food means it has to be clean easily. Wherever food touches should be cleanable, user accessible, there and it should be made of food safe material, right? So getting that right, getting the sanitization friendly design and getting the food safety right itself is a lot of challenge because like there will be one case in which food will go somewhere where it can't be clean, then entire design has to be revised, right? So those are the key challenge we had. And obviously on non-technical side, right?
Mm-hmm.
Um, Building hardware company poses its own challenges. Firstly, the investment, like getting investment for a hardware company is not as smooth as a software company, right? Second is getting right talent, right? So I would say hardware talent and mature hardware talent is very limited, right? So getting them on board and getting them right is one of the another big challenge. Um, and third is like working with vendor, supplier to get quality timeline right is also another challenge. So, like making sure that this product get designed, manufactured India. Um, Actually, manufacturing in India is not as easy as it is like maybe in China or Vietnam because the vendor network work very differently here, right? So the professionalism, the time commitment, all those things are actually little shaky. So getting all those right is another challenge that we have faced.
Because you have your in-house design team, it is like everything made is in-house,
Yeah.
or you're sourcing it from outside.
So so like see our problem is very different from what exists, right? So the thing is we have to build system from scratch. So most of our system and parts are very custom parts, right? But though it is a new problem there that we are solving, we always had this in this fundamental thinking that whatever is what you buy it, not make it, right? So I don't have to reinvent my power supply, right? Power
Mm-hmm.
supply should be a what power supply. Wherever you can create customer value, that only you touch. Otherwise, use as many of the cell component as much possible because proving a design, proving a component is a lot of effort, like a lot of testing, lot of effort to prove one component. So our idea is like use proven part. So the exposure to testing, the amount of time we waste in testing also reduces the effort, time, effort, everything reduces. To use proven component, it was the thing we followed. So don't reinvent the wheel. Where you can create customer value, touch those points only was our
Okay.
thinking.
Okay, so talking about the technical challenges you faced, so how did you overcome those challenges? Like you were building versions out of versions, or how did you tackle those situations?
So there's no easy way out, right? It was always been build
Uh,
version out of version, like iterate
mhm,
your design, right? And then have some fundamental philosophy built in. Because when we are inventing from scratch, right? What happens is there are a lot of opinion, there are lot of ideas that come to your mind, and if you don't have underlying thought process, it becomes very hard to make a decision. Third thing is like we had a lot of brainstorming. So brainstorming is something that help us come up with a good solution for the problems, right? But like I think the most important part is building quick prototypes, building and testing it out, right? Uh, so we have this thing like don't keep discussing, keep building, right? So you have a brainstorming session and you can most of time conclude what will work, what will not work in a brainstorming. Just that idea will come in. So build a prototype, right? Build a
mhm.
prototype, test if it will work or not. So that has been our approach. Like don't waste too much time on discussion, just keep building, right? So that's the approach we took.
Okay, so building a prototype of like the hardware thing you have prepared, so it can be very costly for you also. So how did you manage that?
Yeah, it is costly, right? And a lot of time, like if you, un so it is costly, and we have been fortunate that we never had a constraint on prototype budget, right? So we had constraint on like whom do you hire, what kind of salary we can pay, but we never had a constraint on prototyping because we got lot of government grant, and this government grant was mostly for prototyping. So I might not have money to pay for salary, but I always had money to do prototyping because most of the government grant actually gi- uh, they don't restrict on prototyping expenses. They restrict on the person expenses. So we that's why we spend good amount of time on prototyping. And a lot of time, what happens is you have to simplify, right? So, like when you are saying that you have to taste a thing, you have to go down and very crisp define what exactly you are tasting, right? So, um, like very simple example, right? Let's say you are dispensing. So you have to taste that will my vibration based mechanism will work or not, right? For let's say dispensing, I'm just putting across. Right? This is not something we are using, but
Mhm,
I'm just putting across. Like say, uh, will my vibration based dispensing work or not, right? So what you do is get a thing, uh, and like you don't make an entire product which is based on the vibration based dispensing. You just make one simple prototype and then maybe a bowl kind of thing or a funnel kind of thing, and see if you can measure the quantity, you can control the quantity precisely, right? So uh, very low level you have to define your problem and prototype it so that your cost is also in control, right? So it is not that um, actually going there, right? Like making from the hypothesis, making sure you define your testing philosophy very well, like what exactly you are testing, what hypothesis you are testing. That defining very well, you can always come up with a cheaper way of prototyping and testing. So,
mhm,
and a lot of testing we did through 3D printing, right? So 3D printing and DIY hardware was our thing. So with that, we could prototype very quickly. We can make, break things, right? So
mhm.
uh, that's the approach it worked for us.
Okay, so you did step by step prototyping.
Yeah. So let's say I am working on my new stirrer, right? So I don't
Mhm.
make a entire product with a new stirrer. I just prove the stirrer, right?
Mhm.
So that's how it worked. So we always thought in a subsystem way or a core hypothesis way so that we can quickly test and prove it.
Okay, so basically it is a technology innovation, right? So, can you tell us that how the electronics is involved in this all process?
Yeah, so electronics is the what you call electronics is the engine, right? In this. Um, so you have all the motor controls happening through electronics, right? So you have a lot of sensing that goes on. So how NOS works is it has a camera overlooking the pan, and there is a AI that run on a edge, so that whatever is the like when we cook, how you make a judgment, right? It is let's say onions are caramelized, your curry has released the oil, your rice is fluffy. All those things we do through Edge AI. So what we do is that so electronics actually connect everything, right? So you have the mechanical assemblies, but finally they run through a motor, and motor is controlled by the electronics. So um, like electronics is the engine behind it, right? So we have the PCBs. In fact, we have like in entire thing we have like eight PCBs that goes in. Eight different type of PCB that goes in
Mhm.
at different part. Like some are sensors, some are for the actuator, some the main motor control, the intelligence unit. So all those work together to get things done, right? So electronics is very core part of the entire product.
Okay, so what role does sensor plays in cooking process?
Thus we say about cooking, right? Um, Then we need camera cooking the pan. We have a thermal array which analyze the temperature across the pan and make also aid into the decision making. We have uh, the torque sensing, meaning when you stir, how much force is getting put on the stirrer. Also determine how thick the gravy is, right? So we had that also. These are three core sensing that bring the intelligence. Like this is for the culinary intelligence, so to say, to figure out if food is cooked properly or not, right? Other than that, there are a lot of because there's a moving part, right? You have to have a position of it very accurately. So there are lot of position related sensor like photo interrupter or rotary encoder. Then your we have a time of flight, water and oil level sensors, right? So there are a lot of sensors actually come together to make the system work. Um, then we have, yeah, uh, like lot. So also, let's say, see, it is a home product, right? So you should make sure that when it is in use and kid comes in, it should make sure that they don't get pinched, right? So they there has to be safety built in. So a lot of sensor comes in from the safety angle as well, saying that if something is hard coming in my way, I should stop the motor, right? So a lot of sensing goes that way, like for the anti-pinch technology, and uh, then like what if this is a food, right? And people can put any type of food in the pan. What if it cause fire? Then the fire safety related sensing, like so you have a temperature goes beyond this, it has to stop, everything has to stop, right? So safety also bring in lot of sensing that is required to make sure that people are not getting affected by the product.
Okay, okay. So, NOSH also replicate the traditional techniques like, tadka and slow simmering, right?
Yeah. Like
Mm-hmm.
just to elaborate on the first part, right? So first year, when we are building, we were like, the taste has to come out well, and only way it can come out is we don't change anything in the process. Because the process we change, the taste will be different. Like, so that's why, so first idea was people should not say that this is a machine cooked food and this is a hand cooked food. Like they should not separate it like that. It should be like not differentiable from machine cook or hand cook. So first year we were even that way thinking that if taste will not come out well, we'll close the company. Will not bring the build the product if we can't achieve the taste. So taste has been always the priority for us.
Okay, so how did you preserve the flavor and texture and aroma, and what would your test plan look like to do that?
So the process wise, right? When you cook something, there are let's say you make a paneer curry in your pan. So you start with oil, uh, add aromatics could be your dry spices, your wet spices like ginger, garlic, etc. Then your onion and tomato, right? So and then paneer. So however it has been done, like however the process was done before NOS and after NOS is same, right? It is like instead of you standing and cooking on induction, the robot is cooking it or it is doing the stuff so that it gets cooked. So the heating process, the dispensing, so dispensing we got very, very accurate. And the heating process, the mixing process, we made sure that it is exactly replicating the human motion, right? So the outcome should be same. In fact, to achieve that, we um, we actually had a 25 plus iteration on the stirrer design. Okay. To make sure that stirrer work nicely in this. Like so that is how we iterated because taste was the thing in our preference. On the tasting side, right? So actually tasting keep happening because whenever culinary team, which are like a um, few chef who has worked in a five-star hotel coming and building recipe for us, right? So we have an in-house culinary team uh, who keep on developing recipes. So they build the recipe and then we go through a testing cycle of it. The testing cycle looks like the taste of it and then the repeatability of it, right? So same day you cook, maybe the same taste will come, but after 5 days you cook, can the same taste come up, right? So we have that repeatability study for the recipe. So with that, we could achieve the taste, right? And so now taste is also it's like it's in your tongue, right? So different people like different things.
Mm-hmm.
And that has been always a challenge, right? Uh, so we also bringing the customization part of it. So you can actually customize your salt level, spice level, and the fat level. And yeah, salt, spice, and fat level you can customize. You can also edit the recipe that are preloaded. So you can adjust the
Okay.
cooking timings, you can adjust the ingredient you like, not like kind of thing. You can swap your ingredients. So that's what we built to get that personal preferences get covered so that
Mhm.
everyone has a their own way of getting food.
Okay, so
So
you talked about the cooking timing. So how much time is generally takes to, prepare a dish compared to the traditional method of cooking? Like if I'm comparing a single dish with the traditional method of, cooking. So is there a difference of timing or it is doing it in the same time?
So it is doing at the same time. Most of the cooking it does at the exact same time, right? So let's say something like poha will take 10 to 15 minutes, upma will be 15 minutes, something like biryani will be like 45 to 50 minutes, right? So
Mm-hmm.
it takes the same time as it takes outside. And this is because we have not changed anything in the process. The process is same. The pan gets heated, you mix the food, and the food get cooked. So it is exactly same how you do outside, also get done in the NOSH.
Okay, okay. You just simply have to load the, oil and your veggies, chopped veggies, and whatever the ingredients are, and then it will cook it automatically, right?
Yeah. So spices, water, and
Mm-hmm.
oil are stored inside only.
Okay.
So it has a spice rack, water container which is 2 liter, oil container which is 1 liter. So your this thing gets stored inside only. Whenever you want to cook, you have to load the fresh ingredient as per the recipe, and it will start.
Okay, so what role AI is playing?
AI role is this, right? So see, your ingredient vary. The tomato you buy today, tomorrow, they don't take same time to cook. Like the time varies, right? So essentially for those variation, when the ingredient vary, you need a sensor to figure out that it is done to the perfection, right? It is cooked to the perfection. So for that reason, the AI really comes into picture. Right.
Okay.
So
Mhm.
right now, like it has camera, torch sensor, and temperature array, with which it can it can actually cook multiple dishes. Like so, it can detect things like, okay, oh, my onion has turned golden brown now. My curry has released the oil now. Right. So those are things it kind of
So,
observe and test, observe and make a judgment for.
okay, so it is connected to the internet, right? The machine is
Yeah.
connected to the internet. So it is, like sending data to the cloud and then, getting these decisions done, or sending data to the edge and getting these decisions
So
done.
this is all processing happening at the edge. So let's say you are
Edge,
cooking.
okay. Mm-hmm.
Uh, it is not that your Wi-Fi has stopped working and cooking will stop, right?
Right,
So
right. Mm-hmm.
it's the edge we are processing entire visual data or the sensor data. Only to get a new recipe or get a new update, you need a Wi-Fi connection. Or if you want to command it from outside, like you want to command it from your yoga class, right?
Mm-hmm.
Then it will require the camera, like
Wi-Fi.
the Wi-Fi. Yeah.
So how IoT is involved?
Yeah, so we use it's a complete IoT solution. Like you can command it from anywhere, right? And it's all done through a lot of protocol that comes inside to make sure that it works beautifully. So yeah, NOS is a IoT device where you can command, you can control it from anywhere. You can pick your dishes, you can update it remotely, right? You can set your preferences remotely. So it's a IoT device.
Okay, so if I like you were talking about steering. So steering like a human hand is, you know, it is
Mhm.
very difficult to mimic. So what actuations mechanism would you consider and why? Matlab, how would have, mimic that thing into your machine?
So see, it is a motor, and for
Okay.
motor, the easiest motion is rotation, right?
Mm-hmm.
So our hypothesis was always, can a rotation motion with playing with the stirrer shape, the spatula shape, right? Can we achieve all type of the stirring, right? So that was the question we had, and with that, I like that's why we took a lot of iteration to get it right, because uh, can the can we achieve the stirring perfection with one type of design of the spatula, which can mimic all type of human motion, right? So see, fundamentally, whatever human motion we have, idea is to that whatever is down, you have to bring it up, and all side of the ingredient has to be cooked, right? So it is actually mixing process, right?
Mm-hmm.
Um so only thing is it has to be make sure that it really happens that well, right? And then you don't have a like something like chicken has a big pieces, something like rava is very fine, right? So all type of this ingredient variation. You have to get a perfect mixing, right? Or a perfect toppling of the ingredient. So we iterated a lot of design and then came up with it. But idea is a single rotary motion it should able to achieve it.
Mm.
We have achieved it also. Yeah.
Okay, so NOSH product comes up with mechanical, electrical, and software system, right?
Yeah.
So what is the biggest integration challenges?
Actually, whenever there's a boundary, right, there is always challenge because I think the largest challenge when there is a multidisciplinary thing come up, when there is a issue or a bug, right? Uh, all the team keep blaming each other, right? Like it is their problem, their problem. But majority of time, the problem is the interface is not well defined, right? So getting those interface well defined, considering all the use cases in which all the scenarios is the biggest challenges, right? So I think cloud to mobile is easy. Then cloud to device is also fairly okay. Uh, from device to the motor controller, right? Is where all the challenges happen because they have to be very much in the sync, and this is all our custom protocol. So that's where majority of the challenges exist.
Okay, so what about the wear of, like, you're using a machine for a certain time and then it starts deteriorating. So like if you're putting the food items also, so how did you prevent that?
Yeah, so basically, that's why reliability I mentioned, right? So we tested this, we keep testing this machine like for 5,000 cooking, right? So 5,000 cooking is something that is like a golden value we target. Roughly, it comes to like 7.5 year of life. So what we do is like every batch of production also happen. We test it for 5,000 cooking, right? So we have that model and we test it for that. So wear off will happen, right? But it will. The only question is, will it survive like 7,000, like 7.5 year of life, right? So that's where we have tested it, optimized it, and make sure that it doesn't fail before that.
And also the clogging and cross contamination can happen, like if you are talking about this spice dispenser and it is not properly dispensing the spice because some clogging is there, so these things also happen, or it depends on the cleaning process.
So it is like it normally doesn't happen, but also it depends on the user, right? So if user keep it for a long time and there's a moisture around, so it might itself get jam, right? Like how our normal spices also get spices or salt from the cubes. So that might happen, but the once it happens, the cleaning is very easy. You remove that old one and edit new one. It is super easy to get it working again. And there's no clogging for which you need to call a service. Like we have a for oil and water also. We have a deep cleaning. So with deep cleaning, you can clean your oil and water hose and pump, etc.
So talking about the revenue, so how many units have you sold so far, and can you share any revenue figures?
Yeah. So actually, we have sold 600 unit so far, right? Out of that, we have delivered 130 unit right now, and other five 500 units are under processing. Like we are delivering. Some are there in logistic, some are there in uh, manufacturing at the production line. So we did a Bangalore. We start Bangalore in August, and then we waited till the early feedback comes in. So we waited for good 6 months to get the result and then proceed. So broadly, we have clocked around 3 CR. Like we have not yet booked the revenue, but that around 3 CR has hit our account from the customer.
So you have your own manufacturing plant in Bangalore.
We work with a contract manufacturer.
So how do you manage that?
Pick a good contract manufacturer, then half of the problems are solved. And then you have a one person managing the contract manufacturer. Typically, works out well.
Okay, and also what teams you have in house? Like you talked about, you have a design team, and what other teams you have in house?
Lot of right now actually it has increased, like, so we have manufacturing team, we have quality team, we have customer support, service,
Mm-hmm.
software, machine learning and AI. Design team also include mechanical, electronics, right, and design verification teams. So then we have business team who handle sales and marketing, operation, HR. So currently, like, it's a full-fledged company kind of thing. We are 40 people in the team right now.
Okay, so when you talk about contract manufacturing or like third party manufacturer,
Mhm.
do you have to protect the design integrity also?
So good contract manufacturer have very strong IP protection mechanism. The
Mm-hmm.
agreements and the way they work are also very IP centric. So getting a good contract manufacturer who respect the IP also become important. And second part is like, you can always break it up, right? So few part is something that you control and you give, then rest of the thing they take care. So not everything be gets shared with one party, right? So we have, for now we have done like that, that not everything is shared with one party.
And also how product testing is handled like by your internal team, since product testing is done by your internal team, right? So
Yeah.
how it is handled?
So like design validation, so we have a lot of test cases for each part of the design, and then we also do a lot of so as I mentioned, right, 5,000 cycles of testing. It's something that
Mm-hmm.
fundamental. So any design changes happen, it has to go through that 5,000 cooking, right? So that
Mm-hmm.
build that trust up. Then also we test it through vibration. So we have like vibration standard for road shipment and ship shipment. We mimic that. We do a drop test. We do the environment chamber test for life. So that way, multiple things we test to get it right.
Also, who manages the sourcing of components? You do it or the your manufacturer do it?
So we have supply chain team
Mm-hmm.
who give credible suppliers, who provide credible suppliers to the contract manufacturer, and contract manufacturer has to get through them it those parts from them itself. So
Mm-hmm.
something they have freedom, like something like fastener, but most of part they don't have freedom to get it from their choice of supplier. It is that we give the supplier and they have to get it from them.
And also, do you have any competition in the market?
Yeah, so Nimble Lab is one of the our competitor. Uh, there are a lot of people building this up, but I think people who have reached the production level are us and the Nimble Lab. So these are the two
Mhm.
companies who have reached there.
So how you differentiate yourself from your competitor?
So actually, it's a design, right? So the look, the feel, the like how the thought process behind it's gone. Like ours is fully front access design, and it's a closed chamber design, so you can command it to cook. You can step it out of your kitchen with confidence, and also that being it front access, you can put it in your cabinet. You can design cabinet with your interior designer, so the accessibility and the placement are become very very easy. Also,
Mm-hmm.
the entire experience of, right, like uh, our idea was like even a kid should able to cook. 6-year-old should able to cook. So the mechanisms are designed such a way that it will like gear and all you will never see, right? So a lot of those things that we have taken care in the design, and that's what differentiates.
And what are the current challenges you have as a startup to grow
So
super
current
fast?
challenge is the market creation, right? So this is a new product, new market, new company. So how to build a market, how to make sure that people adopt this product. Right? So
Mm-hmm.
building adoption for this product is the next challenge that we are working.
Okay, so what are your future plans like? Are you investing in equipment or people, or are you investing in marketing and sales?
Yeah, so all of it, right? So marketing sales obviously will be the larger chunk
Mm-hmm.
because it's a costly activity, unfortunately, right? So
Mm-hmm.
marketing sales, then we also do this. We have this. We are working on the future product as well, right? Also making sure next version of the product, doing the way to optimize the cost, supply chain, right? So basically all teams are there and all teams are working towards getting better things, right? So idea is that, but currently the bigger idea is that, okay, we have built a great product. Can we build a great market for it, right? So how do we create the market for this product is a key consideration for us.
Okay, and also, are you thinking of, having your own manufacturing plant in future?
Mostly not, because I think contract manufacturing is a very good way to tackle it because there is someone who is really expert at manufacturing,
Mm-hmm.
doing the job rather than we coming in, right? So, like just managing that kind of labor, right, itself is a big challenge.
Mm-hmm.
So, our idea is um, build like not to build a factory right now. So factory we will need if our volume don't scale, right? Because essentially contract manufacturers are looking for the larger volume, and if we can't give them and there's a dissatisfaction from their end, then we might have to consider building our own. But otherwise, I think if it all goes well, we never have to build a factory, and we can always rely on the contract manufacturer because that's the
Okay.
expertise, and it
Mm-hmm.
also uh, it's not only the expertise of manufacturing; it's the expertise of finance management, it's expertise of labor management, right? All those are not very easy thing for a technology oriented company, right? So you always have dealt with very high quality people, maybe from good institute and working very diligently versus a worker. So um, we don't want to we don't have that skill set to manage them right now. So
Mm-hmm.
that way we are not looking for it. But yeah, time comes, it's required, and we have to build it up.
Mm-hmm. Okay. Okay. So, are you also looking to add new channel partners or distributor? And
Yeah,
and
so
uh,
slowly we'll build up. Slowly we'll build up.
mm-hmm.
Right
Mm-hmm.
now, we are doing D2C because first we need to learn how to sell it, right? Then we can
Mm-hmm.
pass on that to others, and then they
Okay.
will start acting as a sales channel. So
Mm-hmm.
our idea is D2C and Amazon first, and then go on to retail partner or a distributor.
Okay. So right now the product is online available only, right?
Yeah,
On
yeah,
your website and also on Amazon and all.
yeah.
Okay. Okay. And also, do you have any? Are you also looking for tie up with academia?
Yeah, like so I am from ISC. So ISC is
Mm-hmm.
someone I'm connected with, and we work well together. Other than that, um, like ISC we have good relationship. IIT Madras we are building the relationship now. Then my at back home Surat SVNIT we have good relationship. So um, that way, a couple of institutes we work well. It always helps. Like it always helps to
Mm-hmm.
work with academia also, um, for a deep tech company like us.
Okay. And also about the government funding, are you getting any government funding?
We got a lot of government funding. So as I mentioned, right, we never run out of proto budget because we got a lot of government grant and funding. Almost like
Mm-hmm.
it 1.25 CR is what we got in total
Mm-hmm.
from
Okay.
government, right? So we got a benefit from a lot of government scheme, and it was really helpful to build this product. Like without it, we could have
Mm-hmm.
not reached here because no one actually initially believed we could build this kind of product. and only through government funding we could prove we can raise subsequent round based on that. So yeah. Okay.
Okay. Thank you for your
Sounds good.
time.
Thanks a lot. Lovely interaction. Um,
Thank you.